Hello, Deem Divers. Today we're heading out towards Jupiter, specifically to its icy moon, Europa. For a long time, the picture was pretty simple, right? A quiet, frozen world, maybe, just maybe, a hidden ocean way down below.
Right, that was the speculation. But the James Webb Space Telescope, JWST, has thrown a massive curveball. The latest data shows Europa isn't quiet at all. It's dynamic, maybe even, you could say, breathing. It really changes how we think about finding life out there.
Okay, breathing, I like that. Let's unpack this. JWST used its near-infrared spectrograph,
That's the one.
and I suspect, and it found the surface isn't static, it's active, constantly, reshaping itself.
Exactly.
They talk about these chaos terrains. What are those exactly? Sounds dramatic.
It is pretty dramatic. Imagine the ice cracking, breaking up into these big blocks that drift around and then refreeze, sort of like a giant icy jigsaw puzzle floating on something warmer underneath.
It's like a space puzzle. Wow. And they mentioned Tar Regio as a key spot.
Yeah, Tar Regio is one of these chaos regions they looked at closely. And what they found there is really the core of this discovery.
So what do these chaos terrains tell us? More than just broken ice.
Oh, much more. The lead researcher, Richard Cartwright, found something really interesting. Parts of the ice in these areas seem porous, almost warm enough for the ice to recrystallize very quickly.
Recrystallize, meaning it sort of heals itself faster than we thought.
Precisely. It's reforming, changing, much faster than the old models predicted. And the big so what? Here is why. It strongly suggests materials are actually being pushed up from that ocean below.
The ocean we thought was maybe 20 miles down.
Yeah, roughly 30 kilometers, give or take. So something is connecting that deep ocean to the surface.
Okay, that is huge. If stuff is coming up, what kind of stuff are we talking about? Just water ice?
Well, yes, ice, but a specific kind of ice. Crystalline ice. Think fresh snowflakes, clean and structured, not the damaged, zapped ice you'd expect from all the radiation out there.
So cleaner ice coming from below? What else?
This is the really exciting part. Signs of regular table salt, sodium chloride, and carbon dioxide.
Salt, like ocean salt. And coming from the ocean.
That seems to be the interpretation. As one of the co-authors, Ujjwal Rao, said, the chemistry here is really strange and exciting.
Strange and exciting chemistry, I like the sound of that. What could be driving this? Pushing salt and coar up through miles of ice?
The main suspect is tidal heating. Jupiter's gravity is immense, constantly squeezing and stretching Europa. That generates heat inside.
Ah, the tidal forces.
Exactly. And possibly some heat from radioactive decay deep inside the moon, too. So you get this warmer water, maybe even slush, rising up.
Like a sort of pipeline through the ice.
Kind of, yeah. And when it hits that super cold surface, minus 260 Fahrenheit, it freezes almost instantly. That rapid freezing traps the crystalline ice structure, and crucially, it traps the salts and the kilros that were dissolved in the water.
So the chaos regions are like conveyor belts, bringing ocean stuff up.
That's a great way to put it. Conveyor belts. Constantly recycling material between the ocean and the surface.
It paints an amazing picture, but exploring it sounds incredibly difficult. The radiation, the cold.
Oh, absolutely. The challenges are enormous. Intense radiation, extreme cold, and the surface itself is rugged ridges, shifting blocks.
And you said the changes can happen fast, like in weeks.
Some models suggest yes, which means we need almost real-time monitoring to catch things happening. It's not a static landscape.
Which brings us to NASA's Europa Clipper mission, right? It gets there in 2030. How does this new info impact Clipper?
It makes Clipper's mission even more compelling, I think. Clipper is designed for multiple flybys, mapping the surface, sniffing the thin atmosphere, looking for plumes. But if ocean material is already sitting right there on the surface in these chaos terrains, well, that's huge.
It gives Clipper something specific to look for, a target.
Exactly. It offers this rare natural peek into the ocean without needing to drill down miles. We can potentially sample ocean chemistry right from the surface.
And finding salt, coras, water ice, those are key ingredients, aren't they?
Absolutely fundamental. They're basic building blocks for the kind of chemistry life, as we know it, needs.
So wrapping this up for everyone listening,
Yep.
What's the big takeaway? Does this make Europa more likely to host life?
I'd say it significantly boosts its potential habitability. An active ocean, connected to the surface, exchanging materials, that's a much more dynamic environment than just a static ball of ice over water. It suggests the conditions might be there, perhaps for simple microbial life.
So Europa isn't just this frozen, distant moon anymore. It's alive in a geological sense, shifting, changing.
Full of motion, mystery,
Yeah.
and maybe more.
It really makes you wonder.
Yeah, it leaves you with a big question, doesn't it? Is Europa just another fascinating icy world, or could it actually be the first place we find solid evidence of life beyond Earth? Something to think about.